Now that we know what interval notation is, and with one inequality statement, now we're going to be looking at compound inequality statements. And what are compound inequality statements? It's just two inequalities or more. So we have two inequalities or more joined together with and or statements. Okay, so two or more inequalities, and they're going to be or statements or they're going to be and statements. The first one we're going to talk about are or statements. Or statements just means there's two lines. They face away from each other. They are or statements. You got this line or you got this line that could be a solution. So, for example, these are my inequality statements. Notice it's separated by or, so you must have that written as or. Okay, remember this is detail-oriented. So I always want my target numbers least to greatest, always. So notice -2 is in front, 3 is to the right, always least to greatest. So how would I graph this? Well, it's the same thing. It's closed circle on -2, x is less than -2, so I go all the way to the left. Or x can be greater than 3, so it's not 3, but it can be all those numbers greater than 3. So two lines, one going this way, one going this way. Now, look, because you know that x is on the left-hand side, look at that arrow. I can look from the inequality statement that it's going to be an or statement because you got one going that way, you got one going this way. They're going away from each other, and when they go away from each other, that's an or statement. And it's written in my inequality. And here's what it looks like on the graph. So think about what x can be. X can be all these numbers over here, and it can be all these numbers over here. It cannot be these numbers in here because it's not shaded. So that's what the inequality statement looks like. That's what the graph looks like. Interval notation, it's just two of them now. Where does this graph start? It starts at -infinity, parenthesis around -infinity. It goes all the way to -2 with the bracket around -2 because -2 can be a part of the solution. You must include the word or. Okay? So it's this line or it's 3, parenthesis on 3 because 3 is not a part of the solution, to infinity. And infinity is always separated by a parenthesis. So that's what my interval notation looks like. Always least to greatest. Starts at -infinity, goes to -2, or starts at 3 and goes to infinity. Okay, so when we solve, let's look at number 2. I divide both sides by a -3. What are your rules for dividing by a negative? You gotta flip your sign. So x is greater than or equal to 3, or subtract 5 on both sides, x is less than 1. All right, this is an inequality, but it is not in the right order. Look at your target numbers. Your target number here is 3. Your target here is number 1. You need to put your target numbers from least to greatest. So all I'm doing is I'm simply moving this inequality statement. Ooh. I am moving this one. X is less than 1, and x is greater than or equal to 3. Now my target numbers are least to greatest. And look, that arrow's going that way, that arrow's going that way, so right away, I know it's an or statement. So the only thing missing here is the word or. Now, that completes my inequality statement. Okay, so inequality statement, target numbers, least to greatest. I see the arrows going out, so I must include or. So to graph it, open circle on 1, shade all the way to the left, close circle on 3, because 3 is a part of the solution, shade all to the right. So we read this graph left to right. How far left does it go? It goes to -infinity, parenthesis around -infinity. It comes to 1, parenthesis, because 1 is not a part of the solution. I must include the word or. Starts at 3 with the bracket because 3 is a part of the solution, and it goes all the way into infinity. So that's what my interval notation looks like. All right, let's take a look at one more on number 5. Distribute if needed. I need to. And I'm going to add 3 here. Negative 6x is less than negative 12. Divide both sides by a negative. When you divide by negative, you've got to flip your sign. Okay, over here, I subtract 1. Negative x is greater than or equal to 4. I divide everything by negative, so I flip it, and I flip it. Notice my target numbers. They're not least to greatest, so I have to move them. It's an extra step. I'm gladly going to do that. So now I have x is less than or equal to negative 4. X is greater than 2. I know that my arrows are going out from each other, so I must include the word or. Okay, that's my inequality. It's now complete. So when I graph it, I come over here, close circle on negative 4, shade all the way to the left, open circle on 2, shade all the way to the right, and I know because my arrows are going out. I can already see it in the graph. So how far left do I go? Negative infinity, and it stops at negative 4. Negative 4 is a part of the solution, so you must include it. Got to include the word or. Open circle on 2, all the way to infinity. Parenthesis on 2 and infinity. Okay? That's what my or statement looks like. So what does my and statement look like? And inequalities have a tendency to graph into each other. They're going to graph together. Not always, but mostly they're going to graph together. So here's what this looks like. And look, because my target numbers are least to greatest, negative 6 over here, 1 over here, I can see that those arrows are pointing towards each other, okay? So that's why it's so important to have those target numbers lined up, because you can tell, are they going towards each other or are they going away from each other? So in this case, close circle on negative 6, close circle on 1, and they go together. They go into each other, okay? So all the solutions are right here. So how far left does it go? It goes to negative 6. Negative 6 is a part of the solution. How far right does it go? It goes to 1. 1 is a part of the solution, so blocks on both sides. Now, this is not how we write the inequality statement, okay? It's not how we write it. Or statements are written away from each other with the word or in, but not an and statement, okay? So it's very specific. Because the solutions to an and inequality fall between 2 endpoints, they're frequently written in a more condensed way. So if I take a look at this one, here's what it's going to be written as. All you're doing is you're going to say negative x is less than or equal to x is less than or equal to 1. Now, because the symmetric property, when you move this inequality, this is saying the same thing. I can rewrite this, and look, I put it right here. So it's just a simplified way. It's saying x is in the middle, x is in the middle, you have negative 6 here, you have 1 here, x is less than or equal to 1, but x is greater than or equal to 6 because I flipped it. So notice these arrows are going in the same direction, and they're always going to go in the same direction if you write your inequality least to greatest, which we are. Okay, so let's take a look at number 7. How do we solve these and statements? Well, we work 2 sides of the equation, okay? So we start in the middle, so we got to get rid of this negative 13, so I'm going to add 13 everywhere. I'm going to add it to the left, and I'm going to add it to the right. And I get negative 14 is less than 7x is less than 21. And then how do I get rid of the 7? I divide everything by 7. I divide it on the left, and I divide it on the right. So I get negative 2 is less than x is less than 3. Notice, least, negative 2 is on the left, 3 is on the right, x is in the middle, arrows are going the same way. So my and statement is already written for me. My inequality statement is written for me. So now, when I graph it, open circle on negative 2, open circle on 3, they shade together because it's an and statement. And my interval notation, negative 2 to 3, both with parentheses around them, okay, because they are not a part of the solution. All right, let's take a look at number 9. So how do I get rid of this 1? I subtract it. I subtract it on the left, and I subtract it on the right. Negative 2 is less than 2/3 x is less than or equal to 4. How do you get rid of 2/3? Multiplicative inverse. So you multiply 3 over 2 on the left, and you multiply 3 over 2 on the right, and of course you do it in the middle. That cancels out, and I have x. Over here, I have negative 3 is less than or equal to 6. Notice, it's already written least to greatest. One variable in the middle, they go towards each other. So on my graph, open circle on negative 3, close circle on 6. They go towards each other because it's an and statement. So my interval notation is going to be negative 3 to 6, parenthesis on negative 3 because it's open circle, and a bracket on 6 because 6 is a part of the solution. Okay? All right, one last one. I promised you one last one with 9, but I lied. So let's do one more together. All right, I have to distribute the inside, so I get 2x minus 12. Have to get rid of my 12, so I'm going to add 12 everywhere on the left, on the right. 10 is less than 2x is less than or equal to 16. Divide everything by 2 on the left and the right. I get 5 is less than x is less than or equal to 8. Target number least to greatest, 5 and 8. Perfect. So x is anywhere between those two numbers. It's going to be greater than 5, but it's going to be less than 8. So on my number line, it's going to be open circle on 5, closed circle on 8, and they go together. So this graph starts at 5, it goes to 8, parenthesis on 5, bracket on 8. Okay? If you're struggling with the notation, inequality, or interval notation, or the graph, please come and see me.